So we are at 1 o'clock Central Time. I think we'll get started because this is a session that we have quite a few speakers in it. So my name is Jason Hawkins. I'm an assistant professor in the Department of Civil and Environmental Engineering at the University of Nebraska in Lincoln. I'm also one of the chairs at the conference. So appreciate everyone coming out today. And especially to the speakers. And so our topic is, for this session, there's quite a few different topics. So we're calling it transport policy, buses, and more. And so for the speakers, you'll have 15 minutes, including question and answer time. So it's going to be fairly short. So we're going to hold you pretty close to that. But that means that we'll hopefully get lots of interesting information out of this session today. So our first session is going to be, or our first presentation, sorry, it's going to be Collin Yarbrough. Is that how you say your name, Collin? Great. So if you can, you should go to share your screen now. Okay, great. And just whenever you're ready, Collin.
Awesome. Thank you, Jason. All right, good afternoon, everyone. My name is Collin Yarbrough, and I'm a PhD student and graduate research assistant at SMU's Lyell School of Engineering. I'll be presenting on behalf of myself and Dr. Janille Smith-Colin this afternoon. Thank you for taking the time to learn about this study, looking at the experiences of transportation agency practitioners who engage in environmental justice and community impact assessment at state departments of transportation in the United States. And I'll guide you through our study. Now, our agenda today will go by in a flash, so our presentation structure will follow the typical journal article format. In the United States, transportation infrastructure, particularly automobile infrastructure, has multifaceted impacts on communities, which have historically and disproportionately created gains for white communities and perpetuated inequality for Black, Hispanic, and other historically marginalized communities. As a result, these communities often distrust agencies and projects due to historic displacement, inequitable outcomes, and lack of engagement in the transportation development process. And since President Clinton's Environmental Justice Executive Order in 1994, federal guidelines and definitions of environmental justice, or EJ, communities, have helped push transportation agencies to consider impacts to historically marginalized communities. And much of the extant literature is quantitatively focused on developing policies, methods, and frameworks for adequately identifying and accounting for the distribution of impacts to EJ communities. However, few studies attempt to qualitatively understand practitioner operationalization of EJ or community impact assessment, CIA, within the context of a transportation agency. So the purpose of this case study is to uncover and describe transportation agency practitioner understandings and experiences in their work engaging and evaluating environmental justice communities. We reviewed literature surrounding EJ and CIA analysis and project delivery in these three themes: methodological considerations and analysis, evaluation of agency actions regarding EJ, and existing EJ and CIA practitioner studies. Methodological literature is primarily quantitatively focused, like I mentioned a second ago, and it typically identifies thresholds, indices, and other measures that help practitioners identify EJ communities and identify impacts to those communities. However, literature also notes that research does not always diffuse to agencies at the same rates, and social objectives are not always clearly specified as performance measures in transportation plans. Additionally, in terms of practitioner studies, there are few qualitative studies in the US focusing on EJ or CIA practitioner experiences. And much of the global social impact assessment literature highlights a similar lack of qualitative research. So our research question set out to fill the research gaps in the literature, focusing on the qualitative analysis of EJ and CIA practitioners. This study seeks to uncover how state DOT and EJ and CIA practitioners understand, operationalize, and monitor impacts to EJ communities in transportation project delivery. The context of our case study was set by purposeful sampling and participant bounding criteria, seeking out practitioners in urban and rural contexts across the United States with at least 2 years experience in either EJ or CIA work at state DOTs. When possible, multiple practitioners from the same agency were interviewed to increase opportunities for data triangulation and validity. In total, 20 practitioners were interviewed across 15 states in the US. Regarding demographics of our case study, practitioners had experience ranging between 2 and 30 years. 11 practitioners self-identified as female, 9 as male, and many practitioners interviewed as white, with 2 identifying as Asian and 2 identifying as Latinx. In terms of data collection, ethical steps were taken to provide informed consent and anonymity to participants. Semi-structured interview protocols were developed to elucidate practitioners' experiences and understandings of the EJ and CIA processes in their agencies. Interview lengths ran between 28 to 65 minutes, and all interviews were audio and video recorded. And the initial transcription was carried out through online software, Otter AI, or a professional transcription service, with the research team finalizing the transcripts by hand. And to facilitate further data triangulation and increase trustworthiness of our analysis, we obtained publicly available documents from the agencies for comparison with practitioner experiences. And data analysis was carried out through several rounds of coding, taking raw data from transcripts and memos, and taking that into thematic development to connect themes to contributions in the findings. Through careful analysis, 4 preliminary major themes emerged from the data in this case study relating to variations in practitioner roles, agency contexts, tools and data used in EJ analysis, and impact assessment. Now, data analysis is ongoing, and these emergent themes may adjust as we continue analyzing the remaining 10 interviews. In the interest of time, I'll only cover results from the practitioner roles and agency context themes. In terms of practitioner roles, NEPA, or the National Environmental Protection Act, emerged as a prevailing cornerstone for practitioners to orient themselves to EJ within their agencies, either through environmental review or public involvement in project delivery. And 3 types of practitioner roles and orientations to EJ were revealed through the interviews. We define these as type 1, 2, or 3. Type 1 practitioners often described EJ as part of other environmental review processes they carried out within the broader NEPA responsibilities, and rarely identified specialization in the topic. Type 2 practitioners were formally designated as an EJ or CIA subject matter expert in their department, carrying out similar responsibilities to a type 1 practitioner, but with the added responsibility of being an EJ specialist. And finally, type 3 practitioners operated as dedicated EJ resources in the agency, and their primary responsibility being EJ or CIA analysis or review. And often they described engaging in more formalized EJ policy and guidance development and collaboration within the agency and across agencies in their states. Within the agency context theme, several sub-themes arose. Practitioner and agency perceptions of their state being urban or rural influenced practitioners' understandings of EJ applications within their contexts, and how practitioners in self-described rural states worked within broader perceptions that EJ didn't really apply in a rural context. The concept of EJ champions described how practitioners themselves or other agency personnel, particularly management, positively influenced the uptake and integration of EJ across their agencies, leading to greater acceptance of practitioners' work. Conversely, some practitioners experienced compartmentalization or siloing of their departments or their roles in the agency or on a project, which limited their interaction and ability to integrate EJ throughout the project delivery process. Literature that highlights the importance of a practitioner's ability to influence action within an agency mirrors the emergent EJ champions theme where case study practitioners describe support from management as a force paving the way for staff to implement and integrate EJ policies and processes across their agencies. However, as noted by some of the isolated practitioners, simply having an EJ specialist or a champion alone is not a panacea if the agency context is not set up to support broader action. So agencies seeking to implement greater EJ practitioner specialization could benefit from reflection on their broader agency-wide actions if they and the communities they serve seek to sustain the greatest EJ benefits from further agency development. The key takeaway from the preliminary findings is that in several ways, state DOTs already have tools, processes, and resources in place to advance their environmental justice practices and positively influence EJ-related outcomes in their project delivery. However, the main difference appears to be variations in the way those tools, processes, and resources are holistically leveraged to advance EJ, meaning agencies have potential to further advance EJ outcomes in their respective contexts. Now, the study is limited primarily by the fact that only 1 to 3 practitioners are represented from each agency, and not all states are represented in the study. Future work will look to further identify and develop the categorization of agencies to develop a framework for self-assessment that'll help agencies leverage their existing resources to further advance EJ outcomes in whatever context they may currently operate within. And on behalf of myself and Dr. Smith-Colin, we want to thank the conference organizers, the reviewers, and everyone present at BTR for today for expressing interest in this research. And we do hope that you will reach out with questions, suggestions, and collaboration opportunities. Thanks so much, and we'll now open it up for a few minutes of questions.
Great, right on time. So does anyone have any questions? Oh, yes, okay, so there's one question here. How does your research work with include GARE? I'm not familiar with what GARE is, but maybe that's an acronym that you're familiar with.
It is, and I'm wondering, David, if you can be more specific on that front. That's a pretty broad umbrella there.
To what degree are you working with them?
Oh,
or including their frameworks, or how are they driving your research?
Got it. Perfect. Thank you. So we are using their types of racial equity lenses and other sustainability and resilience models as part of that larger framework I discussed at the end that we're working to develop. So really, this is kind of the beginning stage of a broader framework that we're trying to develop for resilient and equitable project development. So frameworks like GARE and a resilience framework that we're also working with, sensing, adapting, anticipating, and learning. So we are using some of those other great racial equity and resilience and sustainability frameworks to kind of bring all of that under one umbrella. It's a great question because there's a lot of good stuff going on right now. And so we're trying to leverage what's already out there and what agencies also are already operating with.
So are you actually collaborating with them, or are you just taking bits and parts of their frameworks?
Yeah, bits and parts right now. But if there are people from GARE here today, we are open to collaborating with them directly for sure.
Thank you.
Any other questions? We have time for maybe one more question. Yeah, so who's responsible for the implementation, follow-up plans, and strategies? What about sharing responsibility?
Yeah, and so Ahmad, are you talking about in terms of implementation within the agency and following up on impacts and things like that? I'll assume that's the case because I can answer that. And the short answer is it depends on the agency. I think that was one of the things that we learned the most through the interviews is every agency operates within kind of some bumpers, some frameworks, but they all go about things very differently in the ways that they engage environmental justice throughout the project delivery process. Some agencies start really early on in planning and including those discussions in public involvement very early on. Some are just involved in one small aspect, and then the environmental group drops out of the project process and doesn't really come up once construction is complete. And some agencies are looking to follow up and monitor those impacts over the long term. But I think that was the biggest gap is we didn't see a whole lot of response from the practitioners we talked to in regards to how they're following up on mitigation measures, and are the outcomes and strategies they're implementing, are they having the effect that's desired? So that's definitely one gap that we're definitely going to be looking into in the future.
Great, thank you, Collin. And I see there's maybe one or two more questions in the chat box. So Collin, if you may want to answer those in the chat box, we'll move on to our next speaker.
I can do that.
So I believe our next speaker should be Danny Mwangi. Danny, are you here? I think it made you co-host, so you should be able to share your screen.
Thank you very much. Danny is here with that. Danny, unmute yourself. Turn on your video. Danny?
Oh. It looks like he's unmuted himself.
All right. Hello, everyone. Good evening. My name is Danny Mwangi. Presenting on behalf of myself and Dr. Collin Yarbrough from the United States International University, based in Nairobi, Kenya. I'm a fourth year student, currently undertaking applied computer technology, and the paper is on a public transport safety awareness system. I did this as a final year project because I'm passionate about safety in the Kenyan public transport sector. So then, I'm going to introduce the subject and talk about the research objectives.
Sorry, Danny, are you having trouble sharing your screen? It was there for a minute.
Yeah, I'm currently experiencing some challenges. Let me work on it again.
That's fine. While you're getting that ready, I just wanted to point out that one of our goals with BTR is to try to have presenters from a broad range of places. And we're very excited to have a presentation from Kenya this year. We always try to have presentations from African nations, because we generally have very few presentations at conferences, unfortunately. So we're very happy to have Danny presenting today.
I'm sorry.
No, that's okay.
Is it possible to have the next presenter present as I sort out this?
Yep, of course. Yeah, so maybe we'll move on to Michael Tormey. Are you here?
I am, yep.
Okay, great. Maybe I'll make you a co-host here. Oh, there you are. Okay, so you should be able to share your screen now, Mike. Are you able to share your screen?
Sorry.
No, no problem.
Can everyone hear me?
Yeah, I can hear you just fine. Just a note to everyone, if you can just mute yourself if you're not presenting, otherwise I can mute you.
Sorry about that. Let me try that again. Sorry, my internet went out at the perfect time, but okay. All right. Hello, everyone. My name is Michael Tormey, and I'm going to present today on some research I did at the University of Southampton, looking at the development of a comprehensive nationwide walking network in the UK context. And I did this with Dr. Simon Blainey, who's also on the call today. Pretty interesting little project that we did together. So I'm in the UK right now. I'm clearly, you can probably tell, I'm an American. And one of the things that particularly struck me about UK culture on arrival is that walking is really central to life here in Britain. This Reddit post was popular a few months ago asking, do people really consider a 30-minute walk a short walk in the UK? Right? People walk here and people don't mind walking kind of moderate distances. At the same time, walking in the UK is not always easy. This is a picture of me from last December, just covered in mud in the pouring rain, pretty miserable. And also, you know, kind of relatedly, what we see is that people in Britain don't walk enough. The UK is not immune to the global crisis of physical inactivity. And so the problem is, though, that walking is really valuable. Walking has been described as the nearest activity to perfect exercise. It's really healthy, right, both on a personal level and kind of a social level. It's really green, right? It's a really green, emissions-free form of travel. If we're talking in cities about efficient forms of travel, of course, walking is one of them. And, you know, for decades, we've identified communities where a lot of people travel on foot as communities that are really positive, inclusive, vibrant communities socially. And so it's worthwhile for policymakers to think about how we can encourage more people to walk. And in the UK, a new organization has sprouted up with exactly that purpose called Slowways. Now, Slowways has a very particular goal. What they're trying to do is to find a new nationwide walking network that connects neighboring settlements with point-to-point walking routes. So on the left here, this is an image of the network kind of on a really geometric scale, right? They built out this network of straight line points, straight line connections between neighboring settlements. The middle image is the proposed walking routes that people have developed to connect the neighboring settlements. And then you can go on the website and you can click on each one of these and you can look and say, okay, this one between Botry and Gainsborough is 15 miles long. And here's the suggested walking route that's been developed connecting these two neighboring settlements. And the goal of Slowways is to encourage more people to walk further, more often, for more reasons and purposes. But what's unclear at present is this effective? Is the Slowways approach for encouraging more people to walk actually going to do anything? And so that's what I wanted to look at in my research. So the first step was thinking about, okay, if the network is going to be, encourage people to walk, it ought to be a good network. But of course, that means that we need to be able to measure how good the walking network is. And luckily, Slowways had a defined methodology. They said that routes, they had these 10 standards, that routes, they ought to be safe, respect local codes and laws. Luckily, 2 of them, they have to be direct and be off-road, are measurable, right? I can do a GIS analysis to analyze how direct and how off-road Slowways routes are. So kind of as a rough proxy for how good the network is, I did a GIS analysis to look at, well, how direct and how off-road are they? And what I found is that the average slowways route is about 8% less direct than driving, which means that if you drove between any two neighboring points, the distance you have to drive is shorter than the distance you have to walk, perhaps unsurprisingly, but not by much. And the distance you have to walk, about 53% of the average route is off-road, which is actually pretty low, but part of that is related to kind of how I measured that. So, you know, it could be better, but it's not going to get up to 100%, even though Slowways wants it to be. But the more important thing that I found here is that there was a lot of routes that actually just weren't quite, that kind of weren't as direct and off-road as they could have been, right? Like it wasn't necessarily that, you know, the Slowways network was perfect as it was and it couldn't get any better. A lot of the routes were actually just designed really poorly. And so this route on the left was the original route between these two settlements. And because the network is crowdsourced, people can always add new routes to the network. And this route on the right appeared, which is significantly more direct. It's a, you know, it's a better route. But what this demonstrated is that actually the network isn't done, right? And it will continually be improved over time, which led me to my next objective, which was thinking about if the network is going to be continually improved over time, what are the standards that ought to guide those improvements? Is it that we should make routes direct and off-road, or are there other things about which people might care more? Now, if we look at the literature on behavioral change, it tells us that we need to look at we need to target particular users, and we need to target them with the specific things that will encourage them to change their behavior. And luckily we had sort of this with Slowways, had to kind of use some creative analysis to identify these. So Slowways had a survey where they asked 1,000 respondents basically what they think about walking, why they walk, you know, when they go out for a walk, what they do. And what I did with that is I used rough sets data analysis and cluster analysis to identify the group of people in this survey that might be interested in walking, but maybe might be less experienced with walking. The problem, though, is this is a survey of anticipated preferences, intentions. And so we also took data from the National Travel Survey, which was revealed behavior, to identify the people that say they want to walk, but aren't walking. And what we tried to do is build a target population of people who we could target who are interested in walking, but are underrepresented in the walking community. And there was one question in the Slowways data set that was basically like, what do you want to do if you were to go on a walk? Or what do you look for? And I could do some text-based analysis of the target group responses in particular to see that these people in particular care about route attractiveness, navigability, quietude, safety, high path quality. You know, these are things that don't necessarily come out in the Slowways routing methodology, but clearly are things that the target population care about. And so we could also look at this, so that was one I thought about is that, but we can also look elsewhere for maybe what do other comparable networks do to design a network. And the Swiss hiking network is a global best practice. You know, they have a lot of standards, a lot of principles. It's a very good network that's very well used and well loved. And one of the key principles there are that routes similarly should be navigable, beautiful, safe, and persistent, which means, they're always navigable. You can count on them, existing and being able to follow them. And so what I had a set of standards that Slowways wants its network to be designed by, and had a set of standards that we think target users might care particularly about. And those things are not necessarily measurable on a GIS basis. And so the last thing I wanted to do is think about, okay, if Slowways is going to improve its network based on things like easily navigable, quiet, good path quality, can Slowways do that in its current MO, which is virtually plotting a network using crowdsourced virtual data sets? And what I found was basically, perhaps unsurprisingly, no, you can't adequately anticipate path quality using online data sources. So this upper left-hand image, I took that from Google Street View. I anticipated that there would be cows in this field, and when I walked this route, there were indeed cows in this field. I walked this route in the lower left-hand corner. I did not anticipate those cows, and yet I encountered them. Neither of these paths on the right-hand side I knew anything about before I went into walking the routes. And what I found was one of them was really lovely and one of them was not at all. And so in summary, what I had is I had these four kind of key conclusions, which was the Slowways network is not done and has latent potential for continued improvement, but the standards that Slowways is using to target improvement might not be the ones that target users truly care about, but how Slowways is operating at present is probably not enough to improve its network according to those things that target users care about. And so to conclude, we were thinking about how we could, move forward from this and what would be the most effective approach for designing a comprehensive nationwide walking network based on what we learned from Slowways. And we identified this four-pronged approach that we think is really important. We think it's really important that the first step be that you define the needs of target users and then, define the network standards based off those needs of target users. But then it's also important that you collect appropriate and complete data on path quality based on the things that users care about. But it's not just enough that you collect the data, you need to be able to apply the data that you've collected to the design of a high quality walking network according to the things users care about. And then finally, you also need to communicate route quality according to how you've designed your network according to the needs of target users. So this would be kind of our next step, is thinking about applying this four-step process moving forward. But I'll stop there. Thank you very much for your time, and I'm looking forward to hearing your questions.
Great, thanks, Mike. So we have a few questions from David Capelli. The first question is, how did your research address crime? So there's an increase in crime in Western countries, especially violence against women, seniors, Asian Americans, Black people, etc. So I think the question here then is how does your research address crime, and how people who are walking how that might affect people walking?
Yeah, totally. I would say indirectly, specifically with our research, I think it's one of the things that could come out of it's another data set you could apply, right? If you're really concerned about like particular areas or particular kind of characteristics of routes, you could apply that to the definition, but that was kind of not super linked to exactly what we were analyzing.
Mm-hmm. Yeah, so maybe we can, are there any other questions? So David has another question here about social determinants of health. How does your research address this? So many Americans in Western countries have majority or overweight or obese, disabilities, walking infrastructure. So how do these sort of effects, what's the interaction with it?
Yeah, I mean, that's exactly what we're getting at. Is the whole idea here is that we can encourage people to walk by providing them with good walking infrastructure. And of course, that's not the only thing that encourages people to walk. That like if you put someone in there's all this research around your prescription from your doctor will be join a walking group. And what do you know, when you walk socially in a group, you walk more and then you have the good health effects. So there's a lot of things that influence walking behavior. And this is one of the things that came out of Slowways, was that, simply drawing a line on a map, might not be the thing that really kind of changes the game in terms of encouraging people to walk. But there are things we can do with those. We can draw a really good line on a map, and that's probably more effective than simply a line on a map. But of course, that can't possibly be the only thing that's important to the encouraging people to walk.
Great, thanks, Mike. So just in the interest of time, I see there's a few other questions in the chat box. If you want to maybe answer those questions in the chat box, and well, maybe let's see if we can get Danny's presentation up and running again. So Danny, if you'd like to try sharing your screen again. Yep, okay, it looks like we have you. So if you want to, you can just start anytime you like.
All right. From where I am, good evening. It's great to be participating in this conference. I am Downey Mwangi, presenting with Dr. Collin Yarbrough from the United States International University, Africa, based in Nairobi, Kenya. paper is about a public transport safety awareness system. I am a fourth year student, currently taking applied computer technology. This I did as my final year project because I'm passionate about making public transportation here in Kenya safer. So then, to begin with, we're going to look at the problems that I was able to identify and that this proposed system is going to resolve. I'm also going to talk about the system design because I've come up with a prototype of how the system would work and how it will be able to work in the Kenyan public transport sector. I'll also look at the research objective and look at the results and findings from the survey that I was able to carry out, and also look at the benefits that we get by implementing this system in the Kenyan public transport sector. So to begin with, most probably you may not be familiar to the context that surrounds the Kenyan public transport sector. So this picture here shows a sample of what we refer to here as matatus. This is a term that I'll definitely use in the course of this presentation. So mainly there are two kinds that are common. The first one is a minibus, top right, and then bottom, top left, and then bottom right is a van, which on average accommodates 14 passengers. The bus accommodates about 36 passengers. So then the problem that this proposed system seeks to solve is reckless driving. When you look at the Kenyan public transport sector, one of the main things that one would point out as to why most accidents happen is because of reckless driving, and especially by matatu drivers. Secondly, main point was basically a lack of accountability or an incentive rather for disciplined driving. So you would find situations whereby even when the police in charge would probably try to stop a rogue matatu, most of the time you'll find that they get out of such situations through corruption. So then this then paints a picture as to how it really is. Can be able to see that there are matatus that are using walkways that have been designed for pedestrians, which shouldn't be the case anyway. So then this project is relevant to Sustainable Development Goal number 11, which seeks to make cities and human settlements inclusive, safe, resilient, and sustainable. I believe this will be achieved by motivating better driving among matatu drivers, which in turn promotes safer roads for other road users. And the underlying statement being that better behavior among drivers leads to safer roads. Also, this proposed system plays a major role in fulfilling Kenya's Vision 2030, which focuses on promoting safety on the road, which is the objective of the National Road Safety Program. So then, ideally, the system involves a design whereby passengers after a trip can be able to rate drivers, much more like how you would interact with Uber. After a trip, you can be able to rate the driver and then give feedback on how the trip was. And then that rating is available on all, is for all users to see. And then there'll also be the aspect of posting or reading traffic updates, depending on the route that you're taking. You can be able to tag those posts and be able to identify the current condition of traffic as you go along that route. And then depending on how matatu owners would like to implement this system for their circles, you can be able to generate a report for top performing drivers and then create a reward system so that the better behavior among drivers is intrinsic and then goes a long way in making sure that public transport is safer here in Kenya. So then, as I was undertaking this project, the idea was to find out the current challenges that affect the current safety systems that are in place, which to be fair aren't quite many, and then to also in the long run determine the benefits of my proposed public transport safety awareness system. So then I did a literature review, compared other systems that are in other countries. I looked at Cigna in the UK. I also looked at Falk Safe Travel in Denmark. Also looked at Moveit from Israel. To a large extent, they cover things that my system does, and also to some extent doesn't. What you gain from implementing this system is that it is localized to Kenya. And then none of them really involve a feature whereby you can be able to rate the driver. And then also in the long run, I think benefits us because it will be on routes that Kenyans use day in, day out. So then I also carried out a survey, interviewed about 85 people concerning the implementation of this proposed system. When you look at age, most of them are from age 19 to 24. Most of them live in urban areas. The genders are quite balanced. And then on the bottom right, shows the percentage of people of whom I interviewed would like such a system to be implemented here in Kenya. As I pointed out earlier, there were also things that that were key in the survey that I did. And at the top challenge that most surveyed people mentioned was that ideally there was no way to monitor driver safety. So there was no metric, there's no current metric in place to actually measure driver performance in terms of like, after a certain period of time, how well did this driver do these periods? How badly did he do? There's no certain metric at the moment. And then there's the aspect of using unroadworthy matatu driver, unroadworthy matatus on the roads. And then the graph down below shows the benefits that the proposed system seeks to provide. Leading being that it creates a sense of accountability. So then in the long run, you get these drivers who are able to, in a way, get the motivation to be better drivers from within, rather than having external factors that in a way can only take you so far. So then, having done this project, I believe that there's a need to educate the general public that it is indeed their right to safe public transportation and that they deserve better transportation safety measures than the ones that are currently in place. And therefore, in conclusion, I believe that this system will go a long way in creating a better environment in Kenyan roads, so that you get better drivers, better road users, and then also in the long run helps the economy, helps the Kenyan government in that they do not get to spend unnecessary resources on repairing public infrastructure because of the damage caused because of reckless driving. So then, looking forward, I believe that this system can become better by incorporating machine learning, whereby these sentiments are not only analyzed by humans, but rather the system can be able to, after feedback has been given, you can be able to get semantic analysis on the feedback given, and then categorize it whether it is positive or negative. And then from there on, get actionable insights and also get to see how they can be able to reward their drivers to keep that motivation to be better drivers within. There's also the proposed use of QR codes, whereby you can be able to attach these stickers on matatu seats, so that at the end of each trip, you can be able to scan these codes, get driver details, and then give feedback, rather than the current implementation which is in place to manually key in driver details. So then, looking forward to the benefits that I believe this system will bring. As mentioned, we'll be able to monitor driver performance. There will be incentive for proper driving. And thirdly, in the long run, increases passenger safety, which not only helps individuals, but also the country at large. So, well, looking forward, also looking for partners to be able to get this project from the stage where it is from a prototype to get to a pilot phase of this project, so that can be able to launch this project, because I believe it will serve the Kenyan public transport sector in the long run. That concludes my presentation. If there are any questions, I believe I'll be glad to respond to them.
Yeah, any questions for Danny? I think we have a few minutes here we could take. Well, if there aren't any questions for anyone, I have one question. So in the United States, there's sort of a statistic that's often presented about how, you know, greater than 90% of accidents or of crashes in the United States are caused by human error. That's really kind of the final item in the causal chain. And so there's a big push in the community about the fact that a lot of it is roadway design, at least in the United States. And so I'm just sort of curious to get your thoughts on, do you think that the cause of a lot of these crashes or of safety issues in Kenya is human error or drivers? Or do you think part of it is roadway design? Do you think there's any sort of difference in that between Kenya and maybe what we see in the United States?
Well, I think here in Kenya, to a large extent, it encompasses all those factors. There are situations whereby you can attribute certain accidents to bad road design, and then when the road is redesigned, you get fewer cases of accidents. But then there's also the aspect of, when you look at the public transport sector here in Kenya, because it is privatized, you get now these circles pushing for profit, which means that the more trips they make, the more money they get, which means they'll have to speed up to either beat traffic or do dangerous overtakes, which are not necessary. So then, because of the way public transport here is the way it is here in Kenya, you get that the privatization of the public transport sector and the push for profit does not help us in the long run, because you get people with such motives making it hard now to actually police such things. But to a large extent, all those factors play a part in most of the accidents that happen here, but mostly because of driver error.
Yeah. So we have a question in the chat box. Will it be possible for drivers' employers to access this data? So for the purpose of accountability, like you say, and possibly assessment of driver skills to enable them to hire drivers with proper driving track records. So they're saying, think of a LinkedIn app for drivers.
Yes, it will be possible for the drivers' employers to access feedback that passengers would give at the end of each trip. You because we are dealing with the situation as it is privatized. There are circles which own these matatus, and they would like to get how their driver is performing on the road. So yeah, their drivers, employers will get access to a limited subset of the data, not passenger info, not all that, just what passengers are saying about their drivers. And then also, now after all that, you reward your top drivers so that the next month, for example, the next driver would want to be the top driver, and you get to be the top driver because of our proper behavior on the roads. Much like when Uber came here into Kenya, our taxis weren't quite safe mode of transport, but with the introduction of Uber and other online taxis, you actually start to appreciate the taxi sector here in Kenya. Yeah.
Great, thank you. So I think we'll move on to our next speaker here, which is going to be Aditya Medury.
Hi, Jason. Give me, let's see if I can share my screen.
Yeah, I just gave you.
Perfect. Is my screen visible?
Yep, it is now.
Perfect. Okay. Hi, everyone. My name is Aditya Medury. I'm an assistant professor at the Indian Institute of Technology, Kanpur. And this work was done in collaboration with an MTech student, Mr. Mohit Batola, who wasn't able to present today. So the premise of this work essentially is to sort of analyze the impact of pavement conditions, specifically pavement roughness on road crashes through causal inference techniques. I think anecdotally, a lot of us, talk about roads and how bad the roads are, and the roads are causing accidents and things like that. And here's a news article on the right hand side from an Indian newspaper. But part of the reason, we were interested in this particular problem was due to the non-random assignment of maintenance activities. So typically when these kind of studies are undertaken and you take in, you're modeling number of crashes and use a measure of road quality as an explanatory variable, though in an observational setting that becomes problematic because of potential selection biases. And given sort of the increased in sort of adoption of some of these causal inference techniques, we're curious to see in what ways does it modify the effects that we see through sort of naive regression-based coefficient, which captures the when we're trying to seek the quantification of the treatment effect. So in the context of some prior work that has been done, there have been some studies which have looked analysis of crash rates, crash frequency, injury severities, which use roughness as an explanatory variable. And also sort of roughness is a composite measure indicator which sort of averages out the effects of multiple distresses. So in that regard, it's an attractive measure which is also used for maintenance decision making. So using that as a metric was also attractive that way. However, the issue with sort of, as I mentioned, using roughness as an explanatory variable as is without any correction for selection biases is that it's unclear how reliable the coefficient would be. There have been studies and some studies which have looked at before-after studies of effect of pavement treatments on arterials specifically. But there hasn't been a lot of work on sort of capturing, the quantifying the effect of pavement condition on safety in the context of, some of the more recently applied methods and propensity score matching, especially. And given their increasing sort of use in development of crash modification factors, this work was an attempt to, explore some of those methodologies in this context. Just in terms of terminology, to set the problem up, Given that roughness is a continuous measure, in order to apply some of the more readily available methods, especially the most commonly used measures of propensity score matching utilizes binary treatments. So we ended up, segmenting roughness into several categories. So in that context, a pavement so when we do a pairwise comparison, a pavement segment having low roughness is referred to as a treatment group. Similarly, a pavement segment category with higher roughness is seen as a control group. The outcome of interest is annual crashes, and other contributing factors, confounders, or variables that affect only the treatment selection or the outcome. In this representation, I'll refer to it as X in a few different places. So the framework for propensity score matching that we undertook is as follows. First, we had the data preparation. We took data from HSIS and subsetted the roughness as into several classes, and then undertook pairwise comparisons. We first, set off by developing, sort of naive estimation where we had count models and used the treatment as an indicator variable to see what the treatment effect was using those methods. Then we developed, propensity score models, which was essentially can be seen as a binary classification problem. But the interest is more not in terms of predicting the class, the selection perfectly, but to find areas of common overlap, which allows us to then leverage the fact that to develop some sort of a quasi-experimental sort of matched data set. There are different methods for matching based on propensity scores, and we've explored a few different ones. Ultimately ended up choosing a one-to-one matching nearest neighbor with some distance based thresholds, which is referred to as caliper here. Then this is sort of a an iterative process. You do the matching exercise, and then you want to test for how well are the covariates sort of balancing given this selection bias that I was referring to. Ideally, through the matching process, what you want to do is develop a setup where your distribution of covariates in the treatment and the control groups are similar, which are measured through a standardized mean difference or sort of visualization of distributions. And once we have arrive at a matched data set, we can compute the treatment coefficient, the treatment effect through the matched data, and then we try to compare the matched and unmatched data sets through the confidence intervals to get a sense of how much has the treatment effect or the quantification of it shifted. In this context, given that databases which combine pavement as well as crash inventory are limited, we found that HSIS had some data corresponding to Ohio, which included pavement information as well as crash and inventory database. We focused specifically on freeways, where I mentioned some before-after studies and have been undertaken on arterials, but nothing similar has happened on freeways. And to apply some of the binary treatment based approaches, we considered categorizing the continuous variable as such into 4 or 5 different categories based on some classification that we had observed in one of the papers in a similar domain. And this approach has been taken similarly for other variables such as number of lanes or lane width, where people have broken it down into categories. As an example of sort of the naive estimation process, you can see some of the variables that we'd included in the outcome model. And the treatment coefficient here is significant, and it's negative, which indicates that the transition from a poor to an excellent class leads to a reduction in expected number of crashes, which is along the lines of what before-after studies and sort of the naive estimates in the past have shown. And then once you have the treatment, you can estimate CMF by essentially taking the exponential of it, which in this case would give us about 0.77. If you have the standard errors and the 95% confidence interval, that also then gives you the range corresponding to the CMF. Right. So then the question is, how reliable is this estimate given the presence of potential selection bias? And by this, what we essentially mean is the distribution of covariates across these different classes are not similar. So for instance, the traffic composition, in this case, let's say truck percentage in excellent class is greater than the poor class. So that sort of motivates the question in terms of, given that maintenance decision making for different types of functional classes may be different, the prioritization may be different based on how much volume is undertaken. Segments which have more truck traffic would possibly see more deterioration, or the design may have also accounted for that, for example. So capturing those differences would be important. So this is where propensity score estimation comes in, where you're essentially trying to model the decision, the selection treatment, the selection assignment process, conditional on the explanatory variables affecting the selection. So it is actually referred to as selection on observable. So it assumes there is an assumption embedded here that we have captured the relevant variables that impact the selection process of whether a segment is, considered into the treated or the control category. We model this as a binary logit model with, truck and automobile volumes, route types, and variation. In this case, we also found some variation segment length as variables considered for modeling the treatment selection. Then we match observations in the treatment and control groups which have the same propensity score, and then check for the covariate balance to mitigate selection bias. So this is an example of the propensity scores. So areas of sort of where there is no common support are excluded. So there is a loss of data sample when you end up doing this matching exercise, especially in our case when we did one-to-one matching. So you can see that after, when we only considered the matched data set, there is, a strong overlap. This is an indication of sort of what happens in terms of covariate balance. So if you compare the means of these different variables between in the control and the treatment group before and after matching, you can see that after matching, they're all within 10% threshold value, which is sort of the standard sort of measure that is undertaken. So if we have this measure, I mean, the balance is undertaken. So I'll just quickly go through a couple of results. So these are basically showing the point estimate as well as the confidence interval around them of the treatment effect, 95% confidence interval. So one of the things that you see is when you do these pairwise comparisons, keeping poor as the reference category and the control group and reducing the intensity of treatment, in the naive estimation, we do find that as the intensity of treatment drops, the treatment effect reduces, which makes sense intuitively, and it's significant except for the smallest intensity of treatment. However, when we use the matched model, we find that the treatment effect is not significant for all intensities. I mean, except for the poor to excellent. One of the issues, of course, here could also be that we have higher standard errors because we have a smaller sample size. Similarly, we tried to kind of compute these for different types of crashes. One of the crash types which we thought would have been interesting was two-wheelers, given that the balance associated with two-wheelers becomes even more important when you have a good or a poor category of pavement. So we do find the effect to be again strong, but if you consider the fact that you have large standard errors, it's unclear what one can significantly comment about the difference. And here in this case, even with the unmatched data set, sorry, this one's for the unmatched data set, the higher standard errors are also because of the smaller sample means of two-wheelers. So now when I shift from sort of unmatched to the matched data set, you again find a shift towards zero. So there might be some selection bias there, but the confidence intervals overlap. So in conclusion, it's a work in progress, and there are, we're trying to expand upon, sort of overcome some of the assumptions. There is a need to understand the causal effect of pavement condition and treatments on road safety, especially if you want to integrate that into the decision-making process, not just of road safety management, but also pavement management. The application of propensity score methods reveals a reduction in the treatment effect relative to the naive approach, perhaps maybe, but the extent of selection bias is unclear given that the confidence intervals overlap. future research needs to extend the findings to multiple and continuous treatments, given that we've, broken this down into binary treatments. And especially, something that, we're trying to parse out more is, exploring alternate estimation methodologies to merit consideration for endogenous treatment correction, given that there might be hidden bias present and heterogeneous treatment effects. People have observed in the literature that, people might have differential, responses to poor roads. You may slow down, which could make you more cautious. You could become more aggressive by changing lanes. So capturing those through heterogeneous treatment effects might be also interesting. So with that, I'll conclude this flash lightning session. I'm happy to take more questions.
Great, thank you. Are there any questions for Aditya? Okay, well, maybe in the interest of time, we'll move on to the next speaker, and if any questions come up, then we can maybe answer them in the chat box. Great, thank you. So our next speaker is going to be Greg Fountas. Are you ready to go?
Hello, hi Jason. Thanks. Can you see my screen?
Yep.
Excellent. Thank you very much. And I think I am about to start right now.
Whenever you're ready.
Yep. Thank you. Thanks everybody. I'm very glad to be here in this class session of the BTR conference. I am Greg Fountas. I'm an assistant professor in the Aristotle University of Thessaloniki in Greece. And today I will be presenting our latest findings with regard to determinants of our work on determinants of eagerness to use automated buses in Scotland. And of course, this is a teamwork led by Downey and Professor Achille Fonzone from the Transport Research Institute of Edinburgh University and myself. So I don't want to spend a lot of time on things that perhaps you are already aware of, as for example, the benefits that automation technology will bring in the transportation sector, and particularly in urban transport, in urban mobility. And of course, some additional benefits will be brought about by the autonomous buses when, of course, this will become launched at a large scale. And these benefits lie in the areas of enhanced safety because of the removal of the human error, of the increased experience of the passengers, expected experience of passengers with respect to the ride comfort, the reliability, the frequency of services, and other characteristics, operational characteristics of the public transport. Of course, we're expecting significant environmental benefits because of the advancement of the technology that will be used in the automated buses. However, these environmental benefits will become really important and really substantial if we also see an overall uptake of public transport after the launch of the automated buses. And this is the question that actually drives a lot of researchers across the globe to understand how technology perhaps can boost the ridership of public transport services. And this boost is desperately needed across different contexts across the globe. And of course, Scotland, which is the case study of our work, is not an exception. The situation in Scotland is about public transport is not great in the sense that we have seen a decline in bus use over the last few years. And this declining trend has been further exacerbated, of course, by the impact of COVID-19, the impact of the pandemic. Now we are hoping that we are in a post-pandemic stage. However, the ridership numbers do not add up to the pre-pandemic figures. The situation becomes even more serious if we think that public transport constitutes one of the frontline tools and frontline weapons of public policymakers and transport agencies with regard to the decarbonization of transport. And some quite ambitious targets have been set in the National Transport Strategy of Scotland with regard to the replacements of a significant proportion of car trips by public transport trips. In this context, the potential contribution of automation technology to increase the share of public transport is something which is more imminent than ever. In this context, we need to understand first how the technology can be accepted, how the automated technology can be accepted, which is of course a well-documented research topic across over the last few years. However, always there is this major caveat with regard to the uncertainty of the findings, given that we have not seen a large-scale, let's say, launch of the public transport services so far. In this context, in this research that I'm presenting today focuses on understanding some more, let's say, to get some more deep insights with regard to the public transport. In the context of the CAB4 project, which is one of the most ambitious projects in the UK with regard to automated buses, because it will involve the introduction of the first full-size level 4 automated bus service in the UK. Actually, it will consist of a route that will connect the city of Edinburgh in Scotland, the capital of Scotland, with the CAB4 bridge. And in the context of the CAB4 process, we try to identify the pre-trial attitudes and acceptance level of potential passengers of the CAB4 project. So one significant dimension of this acceptance contest in the framework of the pre-trial assessment was to understand which are the determinants, in other words, which are the factors that will shape the eagerness to use the automated buses of potential passengers, and to understand what characterize its level of adoption that perhaps we may see in the future. In this context, we collected some data through an online survey using the Qualtrics platform. The survey link has been distributed to the customer mailing list of the Stagecoach, which is one of the major UK bus providers and one of the partners in the CAB4 project. So all the respondents in the survey have, to some extent, an exposure to bus services. The survey was distributed between 15th of October and 5th of November 2021, and we were able to get responses from a bit more than 1,000 respondents. Assuming that the behavioral mechanism that underpin the future selection and future acceptance of automated buses is quite complex, we tried to include questions that cover a broad range of potential factors that will affect the acceptability of automated buses. So we included questions from travel behavior with regard to travel behavior and attitudes, current travel behavior, as well as travel behavior as amended by the COVID-19, knowledge and attitudes towards technology in general, but also in specific, for example, focusing on technology, on automated technologies in transport, perception and expectations about the autonomous buses and about the potential benefits and concerns that will be maybe raised by the public with regard to the operation of the automated buses, and of course also demographic information and profile information that we always need to control in this kind of behavioral and perceptual analysis. Just to give you a few hints about the profile of the respondents, given that this is not a quota-based survey, so to get directly representative sample, we try to do some benchmarking with some publicly available datasets to see where we stand with regard to the representatives of the particular population that uses public transport. In Scotland, in terms of gender, we saw a more or less, we got a representative sample. We identified some kind of underrepresentativeness with regard to the older respondents, which is something quite frequent in this kind of online surveys. And we also, in terms of bus fare types, tickets, in other words, that are used by the passengers in public transport, we found there's an underrepresentation with regard to the single users, to the users of single tickets. So our survey, let's say, reflects a sample that to some extent is more skewed towards frequent users. We have perhaps an underrepresentation of occasional users of public transport. The question that actually served as the dependent variable for our analysis was that, assume that there will be a trained human safety driver to monitor the roadway in autonomous buses and intervene only if required. If you think about autonomous buses, which statements describe you best, we saw that more than 50% of the population of the sample, approximately 50%, were among the first to use the autonomous buses. Approximately 27% mentioned that they would wait for a while before they use an autonomous bus, an automated bus, whereas 23% of the sample mentioned that it would be among the last ones, or they would wait a lot, or they would never use the automated buses. So from this distribution, it is clear that we have three different categories of eagerness to use. These three categories, so we reduce the eagerness scale to three main outcomes: never or last to use, automated buses wait a while before using automated buses, and one of the first soon after they're available to use the automated buses. The dependent variable in this context is of ordinal nature, so we adopted an order probit framework. And in order to account for unobserved heterogeneity, in other words, the impact of unobserved preferences, taste, or characteristics that are generally present in this kind of survey data, we adopted a random parameter modeling framework, which allows for the impact of some variables to vary across the responses. In order to address more complex layers of unobserved heterogeneity, we assume that the distributional characteristics of the random parameters are not fixed as in most of the similar research, but we assume that the means of the random parameters can also vary as a function of additional explanatory variables. So in other words, we accounted for heterogeneity in the means of the random parameters. We also try to understand if the standard deviations of the random parameters can also vary, by assuming heterogeneity in variances, but we didn't identify statistically significant effects. The results of this kind of models are quite data demanding and quite, I would say, burdensome in terms of numbers. So I try to summarize here the main effects. We saw that older individuals and females are less likely, less eager to use automated buses. And an interesting finding is that people that are located in rural areas are feeling quite attracted by the prospect of using an automated bus. And this is something that triggered also the interest of all the stakeholders when we discussed this kind of results. We saw that people that are reluctant to use any kind of technology are less likely to be early adopters of automated buses. Of course, this resulted in a random parameter with the overwhelming majority here being less likely to use automated buses. People that they can structure their life well without a car, in other words, people that are not dependent on the use of a car for their everyday activities, are more likely to be early adopters of automated buses. People that they perceive the automated buses as trustworthy, people that are familiar with advanced driving assistance systems, people that they expect significant improvements in terms of the ride experience when with the automated buses. All these three categories are quite favorable towards being early adopters of automated buses. People that they expect new bus routes with automated buses are have more, let's say, splitted perceptions towards automated buses. As we see, 57% of these are more likely to be late adopters, whereas the rest are more likely to be early adopters. People that are currently satisfied with bus service are more likely to be the early adopters of automated buses, whereas people that have increased their driving during COVID-19 are less likely to use automated buses as early adopters. I know that we are running out of time, so I will skip this variable just to this slide, just to let you know that we identified that the employment status actually decomposed heterogeneity significantly of some random parameters, and this is something that requires further investigation. And overall, if we summarize all our findings, we saw that generally people that they are reluctant towards technology are less likely to use automated buses. People that they are more familiar are more likely to use automated buses. Because we calculated also the marginal effects, we saw that the comfort of ride is one of the strongest determinants of favorable perceptions towards automated buses. Of course, we saw that female and other passengers are less attracted by automated buses. People that they are not dependent on car are also more attracted by automated buses, as well as people that were satisfied. And rural residents is among one of the strongest determinants of the eagerness to use automated buses. And in this context, we can see that there are specific groups, specific categories of the traveling population where future interventions can target in order to perhaps increase the awareness or increase the familiarity with automated buses. We have to highlight, though, that this study here assumed that a safety driver, a human and suitably trained human driver will be available throughout the trip with automated buses. However, we don't know if these perceptions will change if there is no any safety human driver in the bus, and this is something that perhaps we need to investigate in the future, as well as something that perhaps we need to further investigate is the role of employment in the adoption of automated buses. We saw that it has a significant impact on the decomposition of the heterogeneity. And it also, another finding that is highlighted from our research is how we can promote trust in using automated buses in the sense that the perceived trust is associated with significantly higher likelihood for someone to be an early adopter. thank you very much for your time. I think I was within the 10 minutes, 10, 12 minutes time frame. I'm available for any kind of question.
Great. Are there any questions for Greg? Okay, well, again, if there's any questions that do come up, feel free to put them in the chat box. And if we have some time at the end, we can maybe take questions then. So our next speaker should be lined up. Anteneh, are you ready?
Okay, can you see my screen?
Yep, just whenever you.
Okay. Perfect. So my name is Anteneh. I am a PhD student at the Budapest University of Technology and Economics. Currently, I'm a visiting researcher in Germany at the Technical University of Dresden. So the study I'm going to present is conducted in Ethiopia, where I'm originally from. So the work has been done in collaboration with Abebe. So we tried to look into the growing mode of transport currently in major cities of Ethiopia. So we picked one of the cities, which is Bahir Dar, for our study. So our motivation was like there is a rapid urbanization. People are in a very, very high rate migrating from rural areas to urban areas. And the informal transportation system or the paratransits are becoming the main or playing the main role in the mobility system, not only in Ethiopia, actually in other low and middle income countries also. So we're specifically interested in the motorized three-wheelers. We locally call them bajais. In different places they call them tuk-tuk and rickshaw also in English. And so we use interchangeably bajas and motorized three-wheelers in this presentation. So there is a heated debate now taking even the mainstream about this kind of transport modes. So just to assist in policymaking or resolving the discussion or the debates, we were interested to look into the perceptions of the users. And we couldn't find prior studies conducted on the topic, at least to our knowledge. So that was actually our main motivation. So we tried to provide some insights through some online surveys and analysis. So Bahir Dar is like hosting very different kind of modes of transports, from cycling to three-wheelers, minibuses, and buses and private cars, quite mixed. So the three-wheelers has a significant share in this nature of mobility. So finding some insight from this kind of mode would mainly improve the overall mobility. So the approach we followed to conduct this study was a 5-point Likert scale online survey. So we collected 150 responses. And we tested whether our data set is normally distributed or not, and we found out that it's not normally distributed. So we went for the ordinal logistic regression model technique. Then we finally also analyzed the Spearman's rank correlation to see the relationship among the variables. Okay, so here is figure 2. It's showing the modal share in the city of Bahir Dar. So as you see, the light blue is the taxi or minibuses, the blue and white popular minibus taxis. And the second highest share is Bajaj or the motorized three-wheelers. So it's really quite interesting. And we asked respondents what is their main reason or are main reasons for them to choose this kind of transport mode. And from their response, we have seen that they were given a chance to pick more than one or two answers. So 57% of them said that the mode is fastest, actually the less travel time. So we just made the technical terms somehow easier for them to understand. The second highest was reason was the mode is flexible, especially for the last mile connection. And the third was the mode is comfortable. So comfortable, we understand this or interpreted this as the boarding alighting situation is easier compared to using other mode of transports. And the least ranked reason was the driver's behavior or discipline. They were not like behaving well. So that's also related to the training, the poor training system to the three-wheeler drivers. So we aggregated the questions into three bigger classes. So some of them in category one as a driver behavior or passenger behavior. Category two was related to the vehicle, was about the design, the comfort, the seat belts, and speed of the vehicle. The third category was safety. Any question that's related to safety was categorized under the third category. So this will help us understand the main significant variables concerning the motorized three-wheelers. So the first step was we tested the normality, and we found out that our dataset didn't pass the normality test. So we went to the ordinal regression technique. So the curves also show that it doesn't pass the normality test. Okay, then the ordinal regression result shows the safety as dependent variable was affected by the driver's or passenger's behavior and the vehicle's design, comfort, and cleanliness of the motorized three-wheelers. So we also checked the test of parallel lines to test if the dataset passes one of the main assumptions of the ordinal regression, which is the proportional odds. So with a significant value, like significantly higher than 0.05. So we concluded that it passes this test. So the driver behavior and the vehicle predicts the safety directly or proportionally. So when the respondents rate the driver and vehicle low, the safety outcome would also be low. So we also checked the model fitting information and the goodness of fit. So both results showed the model fits our data set very well. And finally, we checked the Spearman's correlation among each variables. Then driver and safety are highly correlated. And one of the other assumption of ordinal regression is multicollinearity. So it shows that like the correlation value among the variables is significantly less than. Literature shows 0.7 as a criteria, so far below 0.7. So they are not multicollinear. So it's still legitimate that we are using the ordinal logistic regression technique. Okay, so from these results as policy recommendations, we came up with 5 basic recommendations. The first is electrification. So as the population number is growing, so does the number of unemployment. I mean, the unemployment rate is also high. So the youth, when even after they graduate from universities, so they see this mode of transport as a means of generating income. So the number of three-wheelers joining the streets are increasing day by day. So at least to contribute towards the reduction of the fuel and for the climate change, electrification would be one possible policy. Now recently, Ethiopia's mega dam began generating electricity, so that would be a blessing here. So the other recommendation is a regulation. So they one of the critical factor or opinion coming from the users is they are not, the drivers are not behaving well, and the fares and the system, in the mobility system, the motorized three-wheelers are the least regulated compared to other mode of transport. So this should be given an emphasis. The other is integrated planning. So planners should always think paratransit as one significant means of mobility in the system. So they should also consider it while planning. So the other is redesigning the streets, especially one of the main concerns is from the respondents is so they feel unsafe when heavy vehicles are overtaking the three-wheelers, and when high-speed cars are overtaking them, they feel unsafe. So maybe designating a separate lane for motorized three-wheelers, since they have a significant share in the mobility system, would be one of the policy directions. And the other is the driver training and licensing. So there is a highly corrupted licensing mechanism and system. So that should be also one of the areas that could be improved as a policy. So as a conclusion, so these results may give some insight toward this, the motorized three-wheelers for policymakers and transport officials in the future. This is actually one of the segment of the total study. It's only based on the public's or the user's perception, but future works will also be done in from the policymakers' perspective, from transport officials' perspectives, from the drivers themselves, the drivers of the motorized three-wheelers themselves. So in that case, we can see a whole comprehensive insight into the motorized three-wheelers. Pedestrians and cyclists also should be considered within the study, because especially in the last mile connectivity, people are using walking as one of a mobility mechanism to get into the main or other conventional mobility modes. So there is a friction between the pedestrians or cyclists and the motorized three-wheelers at the last mile connectivity. So this would conclude my presentation. Thank you for your attention. I would appreciate questions and suggestions.
Great, thank you. Are there any questions? Quiet audience. If there aren't any questions, again, if there are any questions that come up, feel free to put them in the chat box. And otherwise, we can maybe take a few questions at the end if there's time. So thank you, Anteneh. And we'll move on to our next speaker, who is Sijia Sun.
Yeah, thank you. I'm here. I will share my screen.
Okay.
Okay, hi everyone. My name is Sijia. I am a PhD student from China University, China. Currently, I'm a visiting academic at New York University, Abu Dhabi. The topic of my presentation today is assessing the impact of infrastructure features on the energy consumption of mixed phosphate using microsimulation and empirical data. The presentation will be showing the following 5 parts. The first part is research background. Climate change has become a very hot topic because it's not only important for our planet, but also for the shared future of humankind. According to the latest IPCC report, the transport sector accounted for 23% of global energy-related carbon dioxide emissions, reaching 8.7 gigatons of greenhouse gas emissions in year 2019. Among them, 70% of direct transport emissions come from road vehicles. So it's very clear that meeting climate change mitigation goals would require the systematic changes in the transport sector. In order to reduce energy use and emissions from the transport sector, the transition from fossil fuel powered vehicles like gasoline or diesel vehicles to electric ones has been recognized as a promising way. In particular, the bus transit system is very suitable for the implementation of electrified powertrain technology due to its features of well-defined schedules and phased routes. Compared with traditional buses like diesel buses, electric buses have many advantages. To name just a few, electric buses can significantly reduce energy consumption and have the potential for zero emissions during operation. Electric buses can also reduce traffic noise and improve the air quality, especially in metropolitan areas. It was reported that approximately 47% of the global transit buses will be electrified by year 2025. That means there's still a long way to go before phasing out all traditional buses. Nowadays, many cities around the world still operate a mixed fleet of buses, including gas-powered, diesel, and electric buses. How to deploy a mixed fleet of buses to minimize the energy consumption of transit systems is one of the biggest challenges faced by transit agencies. In our study, we address this challenge by investigating the impact of infrastructure features on the energy consumption of diesel buses and electric buses. We acknowledge that there is some research has already identified that several infrastructure features can influence the energy consumption of buses, such as the road gradient, the road lines, the density of bus stops, etc. But there are still some issues remain unsolved. The first one is the analysis and comparison of the difference between traditional buses and electric buses are not enough. The second one is the existing studies mostly rely on limited real-world data sets. This limits the generalization of their results. The last one is none of existing studies investigated different bus line configurations. In this respect, a widely acknowledged belief is that dedicated bus lines guarantee more stable transit operational conditions and a faster travel speed, with a consequent positive effects in reducing the fuel consumption and pollutant emissions of diesel buses. This is because the energy efficiency of internal combustion engines deteriorates in the presence of stop-and-go conditions while increases with the speed. But the energy efficiency of electrified powertrains have a very different patterns. Electric buses are equipped with regenerative braking systems. This system can recover partial energy when the bus is braking or driving down a sufficiently steep downhill. That means when electric buses travel on regular lines, they experience more stop-and-go events, so that they might recover more energy through the use of a regenerative braking system. Which significantly improve their energy efficiency. This makes the environmental benefits of dedicated bus lines for diesel buses potentially less applicable to electric buses. So be motivated by this, in our research, we started by focusing on two specific infrastructure features. One is bus stop density, that is the number of bus stops per kilometer. The other one is bus line configuration. In order to generalize our results, we first use simulation-based approach to investigate the impact of these two features on the energy consumption of diesel and electric buses under both free flow and congested traffic conditions. We also use real-world GPS data gathered in one busy transit corridor in Xi'an, China, to test our simulation results. I first introduced our testing scenarios and the simulation settings for the microscopic traffic simulator Fonzone. In Fonzone, we built a synthetic network, which represents a 1 kilometer railroad with two lines. We consider three network layouts. The first is dedicated bus line layout, which consists of one regular line and one dedicated bus line. The second and third layouts consist of two regular lines. The difference is, in the second layout, we assume the traffic is in a free flow traffic condition, but in the third layout, we assume the traffic is in a congested traffic condition. In all of these three layouts, we will raise the bus stop density between 1 stop per kilometer to 5 stops per kilometer. For each scenario, for example, the dedicated bus line layout with a bus stop density of 3, we run simulations 50 times. In each run, the simulation period is 5,400 simulation seconds, and we use the Fonzone interface to specify the random locations of bus stop density of bus stops along the railroad. For the data-based approach, we use real-world GPS data gathered from one bus route during 1 week in year 2017. There was a mixed fleet of buses operated on this route, including electric buses, diesel buses, and compressed natural gas buses. All the buses were equipped with GPS sensors, which record trajectory information in 1 to 10 seconds. Besides, we use space-time diagrams to identify on which road segments the buses travel at the free flow speed or face congestion. In this study, we used two vehicle activity-based energy consumption models to calculate the energy consumption of these two types of buses. In urgency of time, I will not introduce these formulas in detail, but I would like to stress over one point, that is, in these models, there are only two parameters indeed affect the energy consumption of buses. One is speed, the other one is acceleration, which we obtained from the simulation and GPS data side. Other parameters are just constant ones. In terms of the results section, I first introduced the simulation-based approach results. As we mentioned before, only speed and acceleration affect the energy consumption of buses. So we start from a simple analysis to discuss how changes in speed and acceleration leads to an increase or decrease in the fuel consumption or energy consumption. From the figure in this slide, we can observe that for both types of buses, driving at a higher speed or at a greater acceleration requires more energy. Compared with diesel buses, sudden or the rapid acceleration plays a greater impact on increasing the energy consumption of electric buses. For example, the instantaneous acceleration at 129 seconds is nearly 5 times larger than that at 79 seconds. For the electric bus, the power at 129 seconds is 239% higher compared to the power at 79 seconds. But for the diesel bus, this increasing rate drops to only 57%. In addition, if we combine figure A and figure C, we can observe that when the acceleration is negative, that means the bus is decelerating. The instantaneous power of the electric bus is negative, indicating that the bus is regenerating energy. This is the most unique features of electric buses if we compare it with diesel buses. In this slide, we show the relationship between energy consumption and the bus stop density for both diesel and electric buses. This figure clearly shows that the energy consumption of diesel buses and electric buses is positively related to the bus stop density. It's worth noting that in the dedicated bus line layout and the free flow operating conditions, the energy consumption of two types of buses increases by almost 60% when the number of bus stops per kilometer increases from 1 to 5. But in the congested traffic condition, this increasing rate drops to about 30%, only half that of the other two scenarios. This suggests that the impact of bus stop density on the energy consumption in the congested scenarios is less significant than that in the other two scenarios. Besides, findings from this figure indicate that the optimization of transit networks should focus on the reduction of bus stop density as long as the traveler demand is satisfied. We then describe the impact of bus line configuration on the energy consumption of diesel and electric buses. Figure in this slide shows the relative difference in energy consumption between dedicated bus lines and regular lines. If the percentage value is positive, that means the increase of the energy consumption on dedicated bus lines compared with regular lines. Results show that under free flow traffic, diesel buses and electric buses consume basically the same amount of energy whether they are on regular lines or dedicated bus lines. But under congested traffic conditions, dedicated bus line can significantly reduce the energy consumption of buses. But this energy reduction capacity of dedicated bus lines gradually decreases with the increase of bus stop density. We then conduct, in order to test our simulation results, we then conduct the empirical analysis. This slide shows empirical results of energy consumption of dedicated bus line and regular lines as a function of the bus stop density. We can also observe that the energy consumption of diesel and electric buses is linearly related to the number of bus stops per kilometer. This is consistent with our findings in the simulation analysis. We then calculate the relative difference in energy consumption between two different bus line configurations. We can say that under free flow traffic conditions, the energy consumption of both types of buses on dedicated bus line is similar to that on regular lines. The difference is less than 5%. But in contrast with simulation results, empirical results show a clear difference between diesel buses and electric buses. That is, diesel buses consume less fuel on dedicated bus lines, while electric buses achieve energy conservation on regular lines. The possible reasons could be attributed to two aspects. One is the traffic volume in the free flow scenarios is relatively small in simulations. There are few interactions between buses and vehicles, so that the driving behaviors of buses are quite similar in dedicated bus line and free flow operation conditions. But when we analyze the real-world GPS data, we find that bus drivers tend to drive more intensely on dedicated bus lines with great acceleration. This increases the energy consumption of electric buses more than diesel buses, as we discussed before. And on regular lines, the conflicts with surrounding high traffic can cause more stop-and-go operations, which can help electric buses recover more energy to improve their energy efficiency. In terms of future work, the results I presented today are the preliminary results of our study. So one future line of research is to examine the effect of other infrastructure features on the energy consumption of diesel and electric buses, such as traffic signal conditions, including signal circle, freeze, and efficient speed. Besides, we know that the prominent dedicated bus line might underutilize the road capacity, especially when the bus flow is low. Some research propose modified strategies that can provide bus priority and at the same time guaranteeing the efficient movement of private transportation. So we also expect to evaluate this strategy from an environmental perspective, that is how this strategy influences the energy consumption of traditional and electric buses. This is all for my presentation. Thank you.
Great, thank you. There's one question chat box. I think sort of a clarification. So I think the results, so the question is, the result of energy consumption confused me. Did you mean the electric bus regenerates energy when it decelerates?
Yes, because the electric buses have the regenerative braking system, because this system can recover energy when the bus is braking. So they can recover more energy when the bus encounters stop and go operations. This can improve the energy efficiency of electric buses.
Any other questions for our speaker?
Okay.
Okay, well, thank you very much. And again, if there's any more questions, feel free to put them in the chat box.
Okay, thank you.
Thank you. And we'll now move on to our final speaker, who will be, Pinar Bilgid?
Yes, I'm here.
Great.
So can you see my screen and hear my voice okay?
Yep.
Okay. Hello, everyone. Good evening from the UK. I'm Pinar from the Institute for Transport Studies at the University of Leeds. And today I'm going to present our study about the effects of ride-sourcing services on vehicle ownership in Great Britain. So this is the outline of my presentation. Since its first introduction, ride-sourcing has become very popular across the world, much faster than any other innovation in the personal mobility market. This rapid rise attracted many researchers to investigate these different aspects of this technology. But mostly because of the lack of meaningful data, many areas remain undiscovered, and one of these areas is their impacts. Although relatively short-term effects are more adequately addressed in the literature, the long-term effects, like the effects on the vehicle ownership, still remain undiscovered, mostly because of the newness of this technology. And when the significance of vehicle ownership on mode choice and travel behavior is considered, investigating how ride-sourcing has affected vehicle ownership may be a good starting point to understand broader impacts of these mobility technologies. There is a limited but growing literature regarding the impacts of ride-sourcing on vehicle ownership, but the substantial part of this research focused on the US and China. Only a few studies recently focused on the other countries, and as can be seen as these studies present, mixed findings, which means actually the effect of ride-sourcing on vehicle ownership can be in both directions. So this also shows us the effects of ride-sourcing on vehicle ownership are highly location-specific, and also there is still very limited number of studies that investigate the impact of ride-sourcing on vehicle ownership, which means that it requires more evidence from different countries. Also, substantial part of the research relied on surveys, but the cross-sectional nature of the surveys doesn't allow to reveal the actual causal relationship. So in this study, we aim to contribute to the literature by focusing on Great Britain, which was never studied before. Also, we used 19 years of vehicle licensing data, which help us to reveal the actual causal relationship. So as I said, in this study, we focused on Great Britain. Our analysis covers 19 years from 2001 to 2019. And our analysis unit is local authority disputes in Great Britain. But we excluded some of the local authority disputes because of the small residential population and some discrepancies in vehicle licensing data. So we ended up with 103 local authority disputes with non-ride-sourcing start dates and 12 local authority disputes without ride-sourcing services. So at that point, I need to mention the right sourcing regulations in Great Britain briefly. Before the regulation change in 2015, right sourcing vehicles were only allowed to operate within the borders of the licensing area. But to allow right sourcing services to expand across Great Britain, in 2015, the regulation must change. And as long as the right sourcing operator, vehicle, and driver are licensed by the same authority, they were allowed to operate basically everywhere in Great Britain, which is called triple license rule. So the regulation change has played an important role in our research design because local authority decrees that don't grant right sourcing licenses, they don't hold any right sourcing operation data. So we excluded these local authority disputes from our analysis, and we relied only on the local authority disputes with known right sourcing start dates and with known unavailability. So in our models, we employed difference in differences method, and we followed the fixed effects model specification. The variable of interest here is the right sourcing variable, and we also control for the socioeconomic and demographic characteristics and built environment characteristics as well. We constructed two sets of models. In the first set, we used the official right sourcing start dates, and in these models, we didn't consider the effect of regulation change. In the second set, we considered the effect of regulation change, and in the local authority decrees that right sourcing started after regulation change in 2015, we assumed that right sourcing started in 2015. And for the other local authorities, we used the official right sourcing start dates. We also used two different right sourcing variables in both sets. First is right sourcing dummy, which represents the average change. The second is continuous right sourcing years, which represents the gradual change. So our models find 0.6% decrease without considering the effect of regulation change. When the effect of regulation change is considered, we found further decrease. But these models assume homogeneous response across all local authority disputes, but we expect to see some heterogeneity in different areas with different characteristics. We grouped local authority disputes as London boroughs, metropolitan disputes, urban local authority disputes, and rural local authority disputes. And we included interaction terms into our models to reflect the group-specific effects. Our group-specific effects models found heterogeneous effects across Great Britain. And without considering the effect of regulation change, we found a decrease in London boroughs and metropolitan disputes, but no change in other local authority disputes. When the effect of regulation change is considered, we found further decrease in London and metropolitan disputes, but we also found an increase in urban local authority disputes. So these effects are as expected because as the operation areas of right sourcing services expand and the licensing limitations are eased, an increase in the right sourcing vehicles in London and metropolitan districts may be expected because in these areas the passenger volume is high when compared to urban local authority districts and rural local authority districts. So this increase in the right sourcing vehicles may result in lower waiting times, lower fares because of the adequate supplies and intense platform competition, and hence increasing convenience for the riders that are reluctant to drive but are willing to abandon their cars. This is especially the case in the presence of the good public transit services and with car use restrictions, as in London, because in London, half of the car owners already expressed their reluctance to use their cars because, according to them, car ownership in London is not convenient, but is burden for them because of the car use restrictions and congestion, etc. So this may also explain the increase in urban local authority disputes because in these areas, people are potentially purchasing cars to work as ride-sourcing vehicles in London and metropolitan districts. And this increase in ride-sourcing vehicles seems to dominate the potential decrease that may be caused by the advantages of these ride-sourcing services. A similar effect can be expected in rural local authority disputes as well, but we found no change in local authority disputes. So one potential explanation for this may be the high proportion of elder population in local authority disputes, because in the presence of alternative mobility services, these people may give up their cars. So in this study, we looked at how ride-sourcing has affected the vehicle ownership in Great Britain, and we found an overall decrease in Great Britain. But our group-specific effects found heterogeneity effects across different groups. And our study can be used as a basis when investigating broader impacts of these services, especially on the road to decarbonization. And also, the last but very important point is these studies may give insight into the potential effects of robotaxis because of the similarities between the operation logic and trip characteristics of these technologies. So this concludes my presentation. Thank you for listening to me. If you have a question, I can answer.
Thank you very much. Are there any questions for our final speaker?
No question, it seems.
Sometimes that's a good thing. No, that just means you did a good job of explaining it. Well, if there aren't any other questions, are there any questions for any of our previous speakers?
Thank you.
Okay, well, thank you very much. And I will actually share my screen for a minute here. You should be able to see my screen. So this brings us to the end of our first day of the conference. Just to kind of give you an overview of what we have coming tomorrow. We'll again be starting at 10 a.m. Central Time with our headline speaker, Juan Diaz-Ortuzar, talking about the role of habit in the built environment in willingness to commute by bicycle. And then we have a variety of other sections on sensing, perception, privacy, security, policy and sustainability, walking and micromobility, mobility of care, which is actually a special session that's being organized by the TRB Committee on Women's Issues, which I think will be a really interesting session. And then autonomous and connected transportation, disasters, resilience, and accessibility, and then a session on emerging research. So I encourage you to all come tomorrow. Appreciate everyone coming out today, and thank you to all of our speakers.
Yeah. Oh, buonasera. Buongiorno.